Now let's see about excess 3 addition. There is a small, you have to follow these two rules. So one rule is, when you are doing excess 3 addition, if carry occurs, if carry occurs, we are going to add, if carry occurs, we are going to add a correction of plus 3. Okay. And second rule is, if carry doesn't occur, we are going to add minus 3. So why do you think that these rules are required is, they are just derived from BCD only. In BCD, what happens, if I am adding two digits, let us say x and y, then I got some answer z. But then in excess 3, already we have x plus 3 and y plus 3. That is the meaning of excess 3, right? So everything in BCD is having excess 3. Therefore answer can be 6. So if carry doesn't occur, which means if there is no correction needed, then in that case, instead of having 3 this 6, we have to get z plus 3, then only it will be in excess 3, otherwise it is going to, result is going into excess 6. That is why we are going to subtract 3. In case if we have a carry means we got something which is not in the pattern, therefore correction is we have to add plus 6. Now already plus 3 is the original answer and we have plus 3 because of this plus 6, and now to make a correction factor of total 6, we have to add a 3. Okay, I am not sure if you understood this. If you didn't understand it, leave it. Otherwise, I'll explain you one more time. If you didn't understand it, just leave it and remember this. It is very simple. See, whenever I add two excess 3 numbers, the result which we get may be excess 6, because 3 is here and 3 is here. Just to neutralize that, just to remove that excess of 3, we are going to subtract 3, right? In case if there is a correction required, which means if there is carry, there is a correction of plus 6 required, but already we have plus 3 in it, therefore we are just supposed to add one more 3. Therefore if carry occurs, add 3. If carry doesn't occur, subtract 3. That is how we should do. And one more rule you should remember is, always the inputs should have the same number of digits that the output is going to have. For example, if you are trying to add 7 and 3, the output is going to be 10. Therefore answer is going to contain 2 digits. Therefore you are supposed to add 07 and 03. Always the input digits and the output digits should be same, right? So let us say you are going to add 17 and 3, then the answer is 20. Fine, but don't add 17 and 3, add 17 and 03. I'll explain you the reason now. Fine, let's see some examples here. Let us say you want to add, let's see the case 1, case 2, carry does not occur. So when will carry does not occur? So 7 plus 2. Let's say I want to add 7 and 2. I know that the answer is going to be 9. So answer is going to have single digit. Therefore we need not have 2 digits. Single digits are enough. So let's go with this. Now what is the representation, or what is the pattern that is used to represent 7 in excess 3? 7 is represented using this 1 0 1 0. What is the pattern that is used to represent 2? 2 is represented with this pattern 0 1 0 1. You can check that. You can go to the example previous video where I given you the table and you can check it. Or simple way is, if 7 is in BCD, you add plus 3. Therefore 7 plus 3 is 10. Therefore 7 is represented with 10 in excess 3 and 2 is represented with 5 in excess 3. Got it? Now just do the normal BCD addition, normal binary addition, not BCD addition, binary addition. Then what do we get? 0 plus 1 1 1 1 1. Now there is no carry out of it. Then what did I say? If there is no carry, then you are supposed to subtract 3. Therefore add 3. If there is no carry, then we are supposed to add 3 or subtract 3. If carry doesn't occur, subtract 3. 0 0 1 1. You subtract this. Then what do we get? 1 1 0 0. This is the pattern which is used to represent 9. How? Because the original pattern represents 12 in binary, and you subtract 3, it is going to be 9. Therefore we got this. Now let's see what happens if we get a carry. Now if a carry occurs, we are supposed to add 3, isn't it? So let's see one example for that. Carry occurs means, let's say 7 plus 3. Now we know that the answer is going to be 10, which means answer is going to contain 2 digits. Therefore, you make them 2 digits each. Now add both of them. 0 is going to be 0 0 0 0 and 7 is going to be 1 0 1 0 and 0 is going to be 0 0 0. 0 in excess 3 is going to be 0 0 1 1 0 0 1 1 and 3 is going to be 6 0 1 1 0, right? Now you add them, then what do I get here? 0 here and then 1 0 1 0, we get a carry and then 0. Since I got a carry, what am I supposed to do? You are supposed to add a 3, isn't it? Since okay, we are supposed to add a 3, so what is it? 0 0 1 1. See, since a carry has occurred, we are supposed to add a 3. I have added it. Then what do we get? Here I got 0 0 1 1, which is nothing but 0 in excess 3. Now look at this, 1 1 1, which is nothing but 1 1 and then 1 1 1, which is nothing but 1 1 and then 1 0. Now there is no carry. If carry didn't occur, we are supposed to subtract 3. So 0 0 1 1, you subtract from this is minus 3 and this is plus 3. So we subtract this, what do we get? 0 0 1 0. So this particular pattern, which is 4 in binary, is actually 1 in excess 3. Therefore we got 7 plus 3 as 10. Got it? So I think you understood why we are using the rules of plus 3 and plus minus 3, just to neutralize the answer. Why are we not going for plus 6? The reason is already 3 is included. Plus 3 is always included in the excess, a result of adding two excess 3 numbers. Therefore you need not add 6, you have to add 3 to correct it. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.